Hello, hello, hello. Before we start, within 2 minutes or 3 minutes, so what we're doing, so stay connected with the game. Good morning to all. Today we will study the next topic, cycloid. The cycloid is nothing but whenever any of the curve will roll without sliding or slipping on a straight line or any of the curve, then we consider any of the point P moving on the generating circle which is rolled on other directing circle, then the path traced out by this moving point is known as cycloid. So, to understand better the cycloid, so we will take one example. In this example, consider problem number 22 available on the screen. Draw locus of a point on the periphery of a circle when it rolls on a straight line path that circle diameter is equal to 50 mm, 50 mm. So here, as per our definition, the circle diameter means this circle will roll on a straight line. So the straight line is considering a directing line and the circle will roll. So the circle is considering as generating circle. So step by step we will learn how can we generate the cycloid. So we will consider circle and here so you can read the step so in which first of all we have to consider one complete revolution of the circle. So whenever we consider a complete revolution, so the length of the directing line is equal to the circumference of a circle, then draw a horizontal line. So here in this solution step, from center C, draw horizontal line equal to pi d. Pi d means the circumference of this circle. So the diameter is 50 mm. So first of all, calculate the length of directing line. So you have to draw the circle having diameter is equal to 50 mm. Then draw one directing line. This dimension is equal to this pi d. Pi d is nothing but the circumference of this circle. So whenever this circle will travel along this straight line, it means the distance traveled is equivalent to the circumference of this circle. Now, as per convention, this circle is known as generating circle. This line is known as directing line. So, for each and every types of the curve on later on lecture, so this nomenclature is throughout remains the same. So I directly speak directing circle or line and generating circle. So you have to understand it and you have to remember it. So next step is you have to divide this circle either in 8 equal parts or 12 equal parts, whatever you convenient, with the help of compass. So to divide this circle into 12 equal parts, so use the compass and set the compass equal to the radius of this circle. Then consider these four diagonal points as a center and mark the arc on other part of the circumference. Then join this all the parts so you can easily divide this circle into 12 equal parts. Thereafter, give the name in anti-clockwise direction because this circle will roll in clockwise direction and move from left to right. So, according to or correspondingly, you have to give the number of different division of the circle in compulsorily in anti-clockwise direction. So now consider this circle is divided into 12 equal parts. Now this length of this directing line is also equal to from this point along the circumference and again on the same point. So again you have to divide this directing line into same numbers of equal parts. So you have to divide this directing line which has dimension equal to circumference by using a technique of n numbers of the parts. So already you have done. Then after you have to draw the horizontal line from this whole division from 1 to 12. So you have to draw this whole horizontal line like this. So circle will roll in clockwise direction. So now initially our considered point P is available at the junction of circle and this directing line or the point number 12. Now we divide this directing line by using the compass and oblique line. This method is known as division of a line by n number of the parts. So for that you have to use the compass, set any random radius, then mark on this oblique line up to the division whatever you want to divide this line. So our requirement is we have to divide this line into 12 equal parts. So here you have to divide, mark in this oblique line 12 division. After generating 12 division, you have to join the last division to the end point of the line which will be divided by same number of the equal parts. Then after you have to draw all parallel lines to the last line by using the set square. So this directing line is divided into 12 equal parts. Then draw the vertical line from each and every division up to the horizontal central line of generating circle. Then at the intersection of horizontal central line and vertical line from this division, it will indicate the different central position of this rolling circle. It means that this original position is C0, so circle will be divided into 12 parts. So the total degree of the circle is 360, means we will move the center by one division is equivalent to 30 degree. It means whenever this center will shift its position from C0 to C1, then the point P will move from this position to this position, and this point will attain this division. Same way, by 12 steps, we will shift this center from C0 to C1, C1 to C2, C2 to C3. So, then after, we will mark the position of moving point in respect of the current position of the center. Now, let us we see how can we mark this position. So for that, you have to use the compass again, set the radius of this circle, then C1 as a center, and mark a arc on horizontal line passing from point 1. It means first of all you have to set compass from here to here, radius equivalent to circle, then C1 as a center, and from here you have to mark one arc on horizontal line passing through point 1. So here we get one point. This point is nothing but the position of point P whenever this center will shift from C0 to C1. So this is our first point whenever circle will be available at C1 position. Now we will consider the circle will move again next 30 degree, means center is shifted from C1 to C2. So radius remains same. Again use the compass. So radius equivalent to this circle, but your center is C2. Set the pointer of compass at C2 and mark one arc on horizontal line passing through point number 2. So this is our point P2. Same way, circle will move again by 30 degree. So the center will be shifted from C2 to C3. With the same radius, C3 as a center, and draw a arc passing through point 3. In C4 as a center, draw a arc on horizontal line passing through point 4. Same way, C5 as a center, draw a arc on horizontal line passing through point number 5. In C6 as a center, this is the point P6. Consider the horizontal line point 7, C7 as a center, then draw one arc, C8 as a center, then draw one arc here, C9 as a center, horizontal line is point number 9 correspondingly. Same way, C10, C11, and C12. So, for different position of the center, we have marked the position of the moving point P, then after give the name correspondingly as per the name of this division, then join this all the point from P1, P2, P3 and up to the P12. So we get the locus or the tracing of point P whenever the point P is available on circumference of circle, then the name of this curve is known as cycloid. So I hope that you understand better. And again, I am quickly repeated the process. So the same majority of the procedure step we have to repeat in later on the different types of the curve. So you have to draw a rolling circle. You have to divide this rolling circle into 12 equal parts and you have to give the numbers of this whole division. You have to calculate the circumference of this circle means pi d. Then from bottom you have to draw a directing line by using the end part of a line technique. You have to divide this directing line into the same numbers of the part and draw vertical line from this whole division. Then you have to mark the different center position. Then you have to draw the horizontal line from this all the division, this all horizontal line. Then after again you have to set the distance of compass is equal to radius of this circle means 25 mm. If diameter is 50, then consider the different position of the circle. First, consider the C1 as a center, 25 mm distance in the compass. Set pointer at C1 and mark a arc on horizontal line passing through point 1. Same way, with the same radius as 25 mm for different position means C2, line number 2, C3, line number 3, C4 as a center, line C4. Likewise, this you have to get all 12 points of the position of moving point. Then after you have to join this all the point, then you get your required curve. And the name of this curve is the cycloid. Now, in this case, here we consider the moving point is exactly on the circumference of a circle. But there are other two possibilities. Suppose consider this point P is available between center and circumference. Means Suppose point P is available here, then the generated curve is known as inferior trochoid. Second possibility is, suppose this moving point is not on a circumference but somewhere available outside of the circumference. It means this point is not on circumference but here or any other point, but this point must be on outside of circumference. Then the generated curve is known as superior trochoid. This superior trochoid. In superior trochoid, the moving point P is not on circumference but outside of circumference. So here we will understand this superior trochoid by a problem. So the problem number 23, draw the locus of a point 5 mm away from the periphery of a circle which rolls on a straight line. So considering the same diameter of the circle, and we will generate the superior trochoid. So again you have to repeat the process. Draw a circle with 50 mm diameter, 50 mm diameter as shown. Then draw a directing line equal to the dimension is circumference. This directing line dimension is equal to the circumference of this rolling circle. Then mark the point E, which is 5 mm away from this periphery, and we will trace the locus of this point. So the procedure remains the same. So up to this circle, we have learned the process in the cycloid, but here this point P is not available on circumference of this circle but outside of it at high mm distance. So again you have to draw one circle passing through this point. So from the center to this point, radius is 25 plus 5. So you have to draw one outer circle having radius is equal to 30 mm, 30 mm. Then you have to divide this circle either into 12 equal parts or 8 equal parts. Then after you have to divide this line into same numbers of equal parts. Then you have to give the numbers of the different center position. Then draw the horizontal line from this all division. Then after set the compass equal to the distance CP, because whenever the center C, the position of moving point P is available here, so set your compass is equal to distance CP. Now consider the center C1 with the same radius, means radius is 30, 25 plus 5, then mark one arc on horizontal line passing through point number 1. Same way, C2 as a center, then mark one arc on the line passing through point number 2. C3 is a center, mark one arc on the line passing through point number 3. Same way, consider different centers C4, C5, C6, and on corresponding horizontal line you have to draw the arc. Then give the number correspondingly or respectively as per the division. Then join this all the point. This curve is known as superior trochoid. Why it is called superior? So because the point P is outside of generating circle, for that reason, logically, the name of this curve is known as superior trochoid. Now, second possibility, whenever this point is not on outside, not on circumference, but somewhere available here inside of circumference, then the generating curve is known as inferior trochoid. So, by using the same data, the diameter of generating circle is 50 mm, but moving point position is high mm inside. This is the generating circle. The point P is high mm inside of this circumference. So again, the same procedure. Draw a circle with 50 mm diameter. Draw a directing line. The distance is equivalent to the circumference. Then mark the position of moving point. So this point or all the points available on this circle is high mm inside of drawing circle. Then divide this circle into equal parts either by 8 number or 12 number, doesn't matter. Then mark the initial position of moving point. This point having high mm distance from generating circle, give the number of different division. Here we have divided this circle into 8 equal parts and draw the horizontal line from each division, and also divide this line into 8 equal parts. Draw vertical line from this all the division and mark the different center position of the circle, then again initially set the distance in your compass is equal to Cp. So the radius of generating circle from this point to this point is 25 and this point P is 5 mm inside. So by using this circle radius or by using the scale, set the distance Cp is equal to 20 mm. Then C1 as a center, set the pointer of compass here, mark one arc on horizontal line passing through point 1. So this is your required point or position whenever this center will shift from here to C1. Same way, the line passing through point number 2, C2 as a center and mark one arc here, C3 as a center, line from third division, mark one arc here. Same way, generate all 8 intersections, then give the name of different position, then by join with smooth curve, we will get the curve. The length of this curve is inferior trochoid. So majority means 90% of the process is similar, only we have changed the position of point P. So shortly I am repeating whatever the difference between these three curves. In first case, the point P is available exactly on circumference. The name of the curve is cycloid. Second case, the point P is available 5 mm away from this circumference. The name of the curve is Trochoid, but it is outside, so the prefix will be changed. It is known as Superior Trochoid. Then after, point P is 5 mm inside of this circumference. So again, it is a trochoid, but inside of this circumference, so it is known as inferior trochoid. Now, the next curve is epicycloid. In epicycloid, so one circle will roll on another circle, but outside of circumference, then the generated curve is known as epicycloid. Again, I am repeating, whenever a circle will roll on circumference of another circle, but on outside, suppose consider this is one circle. If any of the circle will available here and it will travel on outside of another circle, then the generated curve is known as epicycloid. So the problem number 25, in which we have to find out the locus of a moving point. For that, we have the diameter of the rolling circle is 50 mm, 50 mm. So here somewhere the rolling circle or rotating circle is available. It will roll on the directing line. This directing line is curvature and it is a part of another circle. The path is having the radius 75 mm. So you have to draw a circle of diameter 50 mm. Then draw arbitrarily one arc having radius is equal to 75 mm. Then we have to find out the length of the circumference covered by one revolution of this rolling circle. It means that whenever this circle will travel without sliding on the outside circumference of this circle, some distance will be covered for one revolution. So join this last point. Suppose this point is the end of this circumference. So find out a subtended angle. It means this circumference pi d is equal to the length of this arc. So this arc is nothing but the radius of this circle into angle subtended by this arc. So pi d is equal to r into theta. So here, first of all, you have to calculate the subtended angle by this equation. Theta is equal to small r. Small r is nothing but radius of this circle 25. Capital R is nothing but radius of this directing circle into 360 degree. Then find out the subtended angle. Then divide this circle into 8 or 12 equal parts. Give the number of the division. Mark the position of point P initially on this diagonal. Then draw the arc from different division and O as a center. So this angle already we have calculated by using this formula. Here you have to consider 360 degree, not 3600, because angle of the circle is 360 degree. So theta is equal to, then you have to divide the calculated angle theta into same numbers of the division. Here we have divided this circle into 8 equal parts. So you have to divide this line into 8 equal parts by measurement. Then draw the line radius vector from this all the division. Then draw the central line O as a center, OC as the radius, and you have to draw the arc. Then you have to mark the different center position. Then after you have to draw the arc from different division by considering O as a center, means set your compass here, set the radius equal to O1, then draw one arc up to the subtended angle. Similarly for point 2, draw another arc, point 3, 4, 5, 6, 10. This is center line, and this radius vector will intersect at different points. This point will indicate the different 8 center position. Then again, originally the point P is available 25 mm from center. So set your compass either utilizing this distance or 25 mm. Then C1 as a center, mark one arc on the arc generated from point 1, means somewhere here. So this distance is 25 mm. Then again C2 is a center, mark one arc on point number 2. Same way, the arc generated from point 3 is here. So center is C3, distance 25 mm, then find the position P3. And consider the arc from point number 4, C4 as a center, 25 mm radius, and mark same way different position. Then after give the name P, P1, P2, P3, P4, likewise P8, then join by smooth curve. This curve is nothing but epicycloid. So again, the possibility for this epicycloid, same way as a inferior trochoid and superior trochoid. Suppose consider this point P is inside somewhere of this circumference, then the generated curve is epitrochoid, but it is available on inside, so it is known as inferior epitrochoid. हेलो। हेलो।
Yes, sir.
हाँ, who has problem? गगन। हेलो गगन। हेलो। Has anyone problem?
Oh no.
हेलो रोहित।
यस सर।
कोई प्रॉब्लम है भैया?
नहीं सर, सही है
समझ में आ रहा है कि कोई दिक्कत है?
सर, थोड़ा थोड़ा दिक्कत हो रहा है।
क्या दिक्कत हो रहा है बताओ ना, तो नेक्स्ट लेक्चर में मैं वो करेक्ट कर दूंगा।
क्या सर?
क्या दिक्कत, कोई टेक्निकल दिक्कत आ रही है, कोई स्पीड ज्यादा लग रही है, ऐसा कोई प्रॉब्लम है?
यस सर, नेटवर्क का सर थोड़ा दिक्कत हो रहा है। आवाज साफ नहीं आ रहा है उधर से जो पढ़ा रहे हैं, तो मतलब आज कुछ देर के बाद सुनाई दे रहा है।
थोड़ी देर के बाद इंटरप्शन हो रहा है ना, टुकड़े टुकड़े में सुनाई
यस
देता
सर।
है।
हाँ
ठीक है। और पढ़ाई सही तरह चल रही है? हेलो।
हाँ सर।
पढ़ रहे हो ना?
हाँ हाँ।
वो जो ऑर्थोग्राफिक वो सब काम चालू है ना, कि बंद कर दिया सब? हेलो। हेलो। रोहित। हेलो।
हाँ सर।
कोई दूसरा कोई कोई क्वेरी है तो मेरा नंबर है, उस पे फोन करके आप सोल्व कर सकते हो, ठीक है?
हाँ सर।
जब भी आपको टाइम मिले, जब लेक्चर ये सब सारे लेक्चर दोपहर को खत्म हो जाए, दोपहर के बाद आप अपनी कोई भी क्वेरी है तो सोल्व कर सकते हो, ठीक है?
ठीक।
तो यू कैन ऑल्सो व्हाट्सएप ग्रुप पे मैसेज भी मेरे को कर सकते हो, अपनी जो भी कोई क्वेरी है तो आप जो क्वेरी को सोल्व कर लो,
सर
ठीक है? तो अभी मैं मीटिंग ओवर कर देता हूँ।
यस सर। ओके सर।